So far we studied, we looked at in a program, we write a program to achieve some specific objective, computation, making an entry, achieve some task. We look at a simple program with drawing polygons, and purpose of using polygons is so that you can see some immediate impact and correlate and trying to evolve how does this using a simple example of polygons would give you basic introduction to programming. So first we draw simple squares and then say if I need to have different square sizes, then we need to have some kind of entity where I can specify the size or the length of the side of a square, and that is where we introduce the notion of a variable. Then we also looked at what is the largest value a variable can store, and we started different types. We looked at binary number representation, and we said if our values are between 0 to 255, a single byte character type is good enough. And then we look at value is 2 power 16 and integer and other variable types. We also took the example of polygon, saying a lot of times we don't need variables that are plain integers. We also need variables that supports fractions, and we look at requirement of supporting fractions, or what we call it supporting decimal, and in the C language we looked at float. We also looked at negative numbers and said we introduced the notion of 2's complement, which is used to represent negative numbers, and that means the most significant bit. If it is 1, it implies negative number. If it is 0, it implies positive number. And then we also said looked at requirement of looping, that whenever we need to repeat something rather than repeating the code, we can just write a loop around and then achieve the task. So far, without getting into details of actually how does C implement these things, I'm trying to give you a broad canvas or a broad picture of my programming requirements. That when you write a program, we need variables, we need to assign values, we need a different variable types, we need to be knowing requirement for differentiating between negative and positive numbers, and we also look at when you have to repeat notion of what is called loop construct. In subsequent lecture, we'll get into details of how to do the assignment, what the program structure will look like. So far, I'm trying to build a general background about programming. And possibly next lecture or next to next lecture, we'll get into actual program, looking at how to use variables, how to do assignment. Today, we'll discuss another construct, which is what I call as functions. When we repeat something, can we define the code or the lines of code as a single entity, single unit, and call them, look, this represents one particular job, and when I want to execute those 5-line statements, I can call a particular identity which you call a function, and it'll achieve the job. And that's the focus of today's lecture would be notion of function, that using a functions, how it simplifies my programming, and we'll get into more details of how to pass parameters, what the return values are, what the actual syntax is. So we'll not worry about those parts today, but in subsequent lectures we'll look at. But today we'll look at the need of using functions. So look at, we started with drawing two squares, and I given the example. I write the code. This is my one square, and then I repeat the same code another square here, if you can look at. And that's what we did, right, drawing two squares. If I need to draw three squares, what I do, I actually repeat this same block. So I have block for drawing one square, that repeat 4 times, forward 100, that means draw a line of 100 pixels, turn left, wait just to so that we can see an impact. And this will draw one square. Now I'll move one line 100 pixels so that I can see second square. Then I repeat the code and the same code 4 times. And then again, I repeat the code 4 times. And this basically gives me 3 squares. Now, if you look at, we are basically repeating this part. In repeating this part, there are two ways of dealing with this case. And one is I can write a repeat loop around 3 squares. Because I have a one block, if you look at this block, which draws one square. This block draws one square, and then forwards it moves 100 pixels forward, and I can repeat whole thing by 3 times. This will give me 3 squares. So just to give you the idea, let me try to run the program here. So let's look at I'll send these programs for you to look at. So look at, I'm repeating the 3 squares, repeating 3 times. I'll get 3 squares, and then I put them in a loop. So see, I'll be drawing 3 squares. One square, I move forward, then draw next square, and so on, so forth. So here, I'm basically, if you look at, I'm repeating the code block 3 times. This one, I repeat, this one, and then I repeat again. Since it's a continuous repeat, I can probably put in a repeat loop. So if you look at the code, again, do not too much worry about the syntax right now. Understand the conceptual, and then we get into syntax next onwards. So here I'm saying repeat 3 times. And what do I repeat? This block of which creates one square. So repeat this block 4 times. So this will again gives me draw 3 squares. So if I were to run 3 squares, loop, which I'm putting in a loop, you'll get the same impact of what we got earlier by drawing 3 squares. Now, essentially, now I can repeat, but it may not be possible to repeat every time. Let's look at if I want to draw something like 2 squares with a gap. Let me show you what I'm trying to draw. So I'm drawing one square, then I draw a gap, and then draw a second square. So I just cannot simply repeat till I move something of that kind. So I just cannot put a repeat loop around because this is a unique. So two different figures. So essentially my requirement is I need to draw one square, move something, draw another square, and that is what we need to be dealing with. And that is where, so can I define a code block which I can basically use repeatedly by invoking that identification, and that is what we call as a function. So if we look at, we've done 3 square loop. So this is my gap. Now, question I'm saying is, this particular block, if you look at, this particular block draws one square of size 100. So I can put this block in this particular kind of identity, which we call function. And rather than repeating this code, we can simply invoke that block by that identity, which you call function, and my life becomes simpler. And that is what we will do. So let's look at what we're trying to do when you define a function. So I define a function, I name it as a square. Right now, do not worry about the word syntax. Focus on understanding the conceptually. So I'm defining a function saying square, and what does square does? It repeats 4 times. It repeats 4 times, forward, left, and draws a square. So this completes my definition. Now, if I were to invoke and use this square in the main program, I can simply say invoke the function called square, which is what I'm doing here. Invoke the square. This will draw 1 square, and then I'm saying move forward 100 line. I'm invoking another function. So with this, when I'm defining a function, now this block can be used any place, any number of times, and that will draw that much square. So this becomes, rather than repeating, putting a loop, I get an independent functional unit. Is something like a package or a block. We did that whole package and zip it up together as a unit. And this works as a unit. Ideally, this even function definition may not be visible to you. Somebody would have written this function and you could have just used that. So this putting a number of statements together, giving them an identity and using them as a single entity is what is the purpose of what we call is a function. So when you look at the invocation of the functions, so let me show that. So I'm defining a function as a square. I'm calling it 3 times. And if I run it, it will simply achieve the same purpose as we are done by repeating. One square, second square, third square, and that's actually what we are doing. Now, if you look at here in our code, I'm calling square forwarding again. This set of statements I'm repeating. So I can actually put a repeat loop and say repeat of 3 or repeat of 4 and simply call once. So if things are being repeated, I can put in a loop. So I can have a function and a loop together that will basically do my job. So let's look at how do we go about doing that. So in that, so I'll basically say, I'll define a function, which is what I'm doing. It is a square, which I repeat. Forward, draw 4 edges, turn left. This is my function definition. And now I need to invoke 3 times consecutively. I put in a repeat loop. So repeat 3 times, square forward, square forward, square forward, and that is my job. So if I do that, it will actually do the same thing what we have done. And I can run that code. You can see that the actual code. So defining a function here, and then invoking this function 3 times. So this becomes a loop, and the loop I'm calling a function. You can actually call one function from another and vice versa, and that will study more detail, study the function called recursion. Can a function call itself? How it does one function call another, and so on, so forth. Let me invoke this function, square function loop. So it will draw the 3 square. Now, if you look at this code, my square block always draws a square of size 100. If I need to draw a square of different size, let's say 60 pixels, that means I need to edit this particular code. And So let's say I want one square of size 100, another square of size 200, another square of different size, then I need to write different functions which is really repeating the code. So I should have a mechanism to indicate that even though I want to use a function square, I should be able to specify what should be the size or length of my side of a square. So rather than hard coding, putting a value 100 into this, can this value be defined as some kind of parameter to the function that I'm calling a square, but make a square of size 60 pixels or make a square of size 50 pixel, 100 pixel, and that becomes a runtime. And when I invoke, I specify what my size is, and that is what is called function with parameter passing. So I can, when I invoke this function, I define this function saying, take a parameter which is called size, and then use that parameter inside, and that means my function has a flexibility where I don't have to hard code. I can use the given parameters and work with those. So we look at a function here. I'm defining. If we look at, I'm defining a parameter called size, and in the forward, which was 100 earlier, I'm using the same value which is given as size here. Now with this, what is happening if we look at? That means when I call my function square, I also need to specify what is the size of each side I want to do, specify the parameter, and when I do that, my function would be drawn, and it gives me a lot more flexibility. So this is what is called parameter passing to the function. I'll again get into more details on what this parameter passing mean, what kind of parameters are there, if there are multiple parameters, what the ordering would be, and what does the void or anything else means. But conceptually, you can look at, I can define a function, pass in a parameter, and use that parameter, and this gives me dynamism, more flexibility of how the square can be used. And now when I want to use this square, main program, so I'm defining a variable called size 60, I'm repeating 4 times and calling square size and forward. Now this will basically, I'm calling the square with size which is 60, so it will draw a square of size 60, and then forward square 100, then I draw 100, and then you see, so it will draw a square. So essentially when you invoke this code, what you'll basically see is in your code, when you run it, it will first draw a square of 60, then I move 100, then draw a square of 60, and so on and so forth. This is how my figure would look like. So let's run and try to see how does this particular code actually works. So I draw one square, then I move 100, then I draw second square, and so on, so forth. Any questions so far about understanding the conceptual understanding? Any questions by anybody?
Sorry.
Please do ask, because otherwise it becomes a monologue and you may not be able to follow. So if any questions, please do feel free to ask. So essentially what we had done, if we look at, we defined a function and saying function, I pass a parameter, I give it a flexibility and use the flexibility to define my different things. And now that we have done, you look at, I can define multiple functions. If you look at when you drew a chessboard, so what we can do is, let me draw a chessboard picture again, even though I will not discuss the code, but I'll give you basic building block of the code there. Let's say, if we look at, I can define one function that will draw a black square. I can define one function that will draw a white square and then keep invoking those functions repeatedly again and again. Or I can draw another function which will consist of one black, one white in a square, or one function which could draw one row, another row. It depends upon how I want to define my functions. So with this function, I don't repeat the code. I use the existing code available. So actually, when you do the programming, it all depends upon how efficiently you can write these functions and invoke those functions and use it properly. And function you pass parameters, gives you flexibility. So let's look at a simple code. How will we define a function for drawing a white square? How will you define a function of a black square? And then if I need to draw just two squares, white square and black square, what would be needed? Let me just show you. It will draw one white square and a black square. Now let's look at how would my code be looking like. I'll draw a white square of whatever given size is. Given this example, can you try to write a function which will draw black square? Spend next 2 minutes and see, can you write the code using simple as a blocks which will draw a black square of the size whatever I'm passing. Spend 2 minutes, try to write, and you can say me, show me and discuss, raise hands, and we can look at. So next 5 minutes, try writing the code for a black square. Let me show you. This is the code for a white square. Now think of how can you draw a black square logically and say, then we define those and discuss it again. So next 5 minutes, try to draw black square and see if you can come up with certain code. If anybody has a doubt, you can ask me. I'll be able to answer. Otherwise,
Sir,
spend time right away. Yeah, go ahead.
could you please, yeah, I just wanted to see the code of the white square.
It is right there. Can you see that now?
Yes, sir, thank you.
This is the code for the white square. This is the code for white square.
Thank you,
Can
sir.
you see that? Yeah.
Yes, sir.
So write the code and tell me how the code will look like to draw a black square. When I given the polygon code earlier, you can look at it. The same thing here. Using only the forward, left, right, only those things you need to draw, nothing else. To turn right, you can do right call, or to turn left, you can do left, and using just forward. Actually, these again, forward, left, right, these again are functions. All I'm asking you, fill in this particular block here. And if anybody has a doubt, want to ask something, Please feel free to ask. I'm giving you a hint and then see if you can proceed further. First, you draw a forward line, turn left, and what you need to do now?
Forward 1.
Yes. You need to draw basically forward 1, left 90, and then
Forward size, right 90.
forward size, right 90, then
Forward 1, right 90.
forward right 90. Anything else after that?
Forward size.
No, we are done with that because now we'll be repeating that.
Okay.
Because then I'll be calling the block again. And since I'm drawing two lines, this line in the forward direction, this line in the reverse direction, and since I'm using 1 pixel length, so I need to repeat only size by 2. I cannot repeat the whole thing. And that gives me a black square. So if you look at my code would actually look like I define my size, I invoke the function white size, and I'm saying move more than two sides so that I can see distinctly black square and a white square, and then I should be done. And that's what the whole code will look like. So if we look at the code, that's how the actual code is. I invoke a white. If I were to not put a forward, what would happen? If I don't want to put a forward, I basically comment this out. What the impact would be, what would you see? I were to comment this forward line, this is what I commented, and I invoke this code, what's that I would see? So let's say if I were to modify my code, any clue what would this draw when I do this? I comment this line, what is the my figure would look like? Any clue? Look, I'm drawing a white square, and when I draw a white square, I'm still here. And at this point, if I draw black square, my square will become right here. So I'll be drawing a white square and it will become a black square on top of it. Let me try to run it and show you. So it will draw a white square and then on top of it, it draws the black square. So maybe you're not able to see that impact quickly. So let me put a some wait period. I draw a white square and let me say wait 5 seconds so that you can see a white square is drawn and then it will be returned. So one white square is drawn, wait for 5 seconds, and on top of it, a black square is drawn. That's actually what is being done. So using different functions, now you can think of how we can draw a chessboard so we can define different units, try doing it, and that's the way it will work. Let me show another function there. Let's see if I can, another code. So look, I'm defining a polygon. If you look at let me remove this so that you don't. So this actually I'm defining a function polygon and I'm giving it two parameters. One parameter is if you look at what is the number of sides in a polygon, is it a square, is it a rectangle, is it something else, and then what is the size of the each side of the polygon. So this is the code. I repeat n times for each side. It will draw a polygon and I'm using a floating point or decimal point or fractional number so that my polygon is perfect. And I invoke this function polygon n sides with a size, n sides with a double the size, n sides with triple the size. And I specify sides as the first parameter. We'll come to those details later. So when I run this code, so look at this code. What do you think my diagram would look like? When I'm defining a polygon, how will the diagram will look like? Any thoughts? Look, first we'll draw a polygon of a given size. Then I'm drawing a polygon of double the size inside, and then I'm drawing a polygon of three sides. So actually, if we look at so if we look at when I draw like a hexagon, my first hexagon would be then double the size, then it will be double the size, and something of this kind. Let me draw and show that to you. It's a hexagon with a size of 50. You'll see three polygons drawn on top of the other. The first polygon, the second polygon will start, and then your third polygon. Of course, this will exceed my canvas size. That's okay, but you can see how the polygons will be drawn. So by using those functions, so I can define a function with one parameter define a function with 2 parameters. I can actually define multiple functions. So what we have done today, if we look at what we have done is we look at function without parameters, plain functions, and then we look at functions with parameters. Then we also look at we can define multiple functions, and that's how we could code. So next class we will look at input and output. How do I get a value from a user? How do I display value to a user? And with this basic construct. So basic constructor understanding of looking at the variable assignments, looking at the looping, how to define a loop, looking how to define a function. Now we'll get into more details of how do we use those structure and how to write actual C program, and then we'll start doing a formal programming. So my suggestion would be practice over, look at it, understand. Next class we'll get into formal programming of how do we write a simple program that makes you these concepts, what the syntaxes for C are, and run that code. I'm done for today. Any questions, please let me know. Otherwise, we are done. Thank you. Any questions, let me know.